Good morning. I may not know what year it is, but I do know JD. And most of you know I grew up in this church, and I invited JD to come share whatever he's going to share today based on a talk that I saw him give at ARE Camp. But I know JD from many, many, many years, and his wonderful wife, Anne, who is with us. He's a very intelligent man that does a lot of work that I don't know anything about. And I'm sure he's won a lot of awards, but the most, important one is his daughter, Robin, who's an amazing individual. And Anne and JD have raised two wonderful children who are now amazing adults. And we've spent a lot of time together at ARE Camp. So you guys, many of you know that's my favorite place in the world. And where we have a beautiful mountain and a valley, which is what I think about when I do the 7 terrace meditation, the basis of the Paul Solomon ILC. So I'm just really excited to hear what JD has to tell us. I know it's all very scientific. I'm sure he could tell us about where he works and all these things that he does. But I think the most important is that he teaches children. That's a lot of what he does. So I thank you for all the wonderful things you do, and thanks for coming here today. JD Stillwater.
Okay. Thank you, Rainbow, for that nice introduction, and thank you for your music. It just put me in a whole different place. Beautiful, beautiful. So, as Rainbow said, I'm JD Stillwater. I'm a science educator from Harrisburg, Pennsylvania. And I guess you could call me a mystic of sorts, but I come to my love of mystery and wonder from a science background. Not what the bleep do we know kind of stuff. Now it's going to not work for me. Here we go. But hardcore, show me the facts, no fooling around, mainstream science. I'm not making a value judgment here. I'm just telling you this is where I come from. My deeper roots, though, are from the ARE community. My parents and my older brother are life members of the ARE, and I'm a past director and program director of the ARE Camp and Rural Retreat. My family also includes a lot of engineers and scientists, so I've always been interested in this interplay between faith and reason, science and spirituality. My worldview has changed many times during this lifetime. But things like healing prayer and reincarnation and auras, all that good Casey stuff, they were always black and white for me. Either I took them for granted as mundane givens, or I dismissed them out of hand as not real. The world didn't really come alive for me until one day during my post-baccalaureate studies at the University of Akron in Ohio. I took a course called Advanced Physics Lab, which included an option to work with a scanning tunneling microscope, which is a really big deal in those days. The STM is the one that can image individual atoms and even push them around one at a time, like this now classic image of IBM spelled out with 35 individual xenon atoms. So the way this thing works is you take a tungsten wire, which is already very fine, and then you sharpen it in acid until it's atomically sharp, with ideally a single atom at the tip, like this drawing here. Can you guys see this? Okay. Then the STM scans that tip over the surface you're imaging back and forth, using quantum tunneling to measure the teeny tiny distance between the tip and the surface. Now this drawing is a little bit inaccurate. The electrons don't actually flow from the surface to the tip. They tunnel, quantum tunneling, which means they disappear from the surface and reappear in the tip without passing through the space in between. The technology is simply amazing. But that's not why I'm here to talk this morning. So at one point while I'm doing this, I crashed the tip, which means I didn't calibrate correctly, and the tip, this finely crafted atomically sharp thing, dug into the surface of the thing that I was trying to image, which happened to be a tiny square of household aluminum foil. Here's a later, more successful image. This is what the shiny side of aluminum foil looks like when you get close to it. Pretty rough. Looks like mountain terrain or something. So crashing the tip was an embarrassing setback, but not that big a deal. But later, when I tried to explain to someone else what happened, I realized something that changed my life profoundly. I realized that nothing ever really touches anything else. Atoms are made of charged particles, with the positive charge all in the center of each atom, with the outsides completely surrounded by negative charge, those electrons that you may remember from your own studies. So from a distance, the positive and negative charges on each atom balance each other out, and there's no repulsion. But as you get really close, every object is surrounded by only negative charge. So when two atoms approach each other, like in this drawing, they repel each other because those negative exteriors repel each other, just like two north sides of a magnet, likes repel. So in the STM, the electric field of the tips atoms repel the electric field of the surface atoms so strongly that it's easier to actually push atoms out of the way for them to touch. So for example, if you slap your hand down on a table, it looks something like this. This is simplified, but the essence is still correct. The space between your skin and the table is very small, but it's never zero. There's just too much repulsive force. Enough to support your entire body if this was you doing a handstand on the table. If some joker leaves a thumbtack on the table, it looks something like this. It's easier to shove the atoms of your skin out of the way than to overcome the electric repulsion between them. Think about this. You have never actually touched anything. Does that have spiritual implications for you? It did for me. So within a year later, I was teaching science myself, and similar realizations began to come, one after another. It's funny how we don't really understand something deeply until we teach it to someone else. So I was having these revelations that are common knowledge to most practicing scientists, but would change the world if average people understood them at a gut level. Understandings that have deepened my spiritual relationship with every aspect of everything. So a few years ago, I put together a talk called 7 Candles to do 3 things. Share some of these revelations from science with others, to offer that reality is inherently mysterious, and to invite the religions of the world to consider science as an ally in their spiritual communities. So today I want to hold up just one aspect, one implication from these revelations, and that is this notion we call oneness. Now you might expect science to be a big party pooper when it comes to unity and oneness, the atheist killjoy in the room. For me, it's exactly the opposite. So play along with me here and let's see what science has to say about unity. We'll start at the very beginning. According to the best evidence science has to work with so far, the universe began as a singularity. What an interesting name, given our topic this morning of oneness. There's a reason it's called a singularity. The singularity at the beginning of time contained everything in today's universe, but compacted, infinitely dense, so that everything in the universe had no volume, no size at all. Everything was one thing, infinitely small and infinitely dense. The Reverend Carol Martinaccio calls it the everything seed, the seed which grew into everything. Now nobody knows what came before the beginning of time, but all the evidence we have now says that at the beginning of time, that singularity rapidly expanded or inflated, creating space and time as it did. Everything in the universe, from this morning's service to interstellar dust in the most distant galaxies, is traceable back to that one single thing at the beginning of time. Everything that's an object, as well as all the things that are energies or events or that are still mysterious, like dark matter, has a common origin, a shared genesis in the Big Bang singularity. So how did all this stuff get so diverse, so separate. 45 years ago, those of you who are old enough may remember that Crosby, Stills, and Nash sang, "We are stardust, we are golden, we are billion-year-old," I see some nodding heads, "billion-year-old carbon." Well, it's literally true. Would you like to know the details? I missed a slide. Here we go. In the beginning, there was only energy. No atoms, no matter, no mass, no space even. No solids, liquids, gases, nothing that we would call a thing. There was only pure energy. Now, matter and energy are like nouns and verbs. Matter is stuff, things, objects. Energy is movement, action, ability. So how did the universe make all this stuff if all it had to work with was pure energy? Well, fusion in stars is one possibility. At extreme energy densities, actually, let's go, I got a little ahead of myself. We'll go back to the very beginning. In the first moments of the Big Bang, energy densities were high enough. In other words, there was so much energy compacted in such a small space that matter, particles, can actually congeal or condense out of pure energy. This happens in particle accelerators, so we know that it's possible. But it requires really, really dense energy, a lot of energy in a very small space. And in the first moments, particles that would later become atoms of hydrogen and helium condensed out of pure energy, just in the first moments after the beginning of time. Now that's worth pausing and considering for a moment. We're talking about something from nothing. Energy's not exactly nothing, but it's not a thing either, not the way we normally think of things. This is a miracle. It's a scientifically described miracle, but it's no less miraculous for us understanding that it happened. So the early universe had atoms of hydrogen and helium. That's great. That's nice. It's a good start. But now what? What can you make if all you have to work with is hydrogen and helium? You can't even make water if that's all you have. So where did all this other stuff come from? Well, fusion in stars is a possibility. Our sun is hot enough that two hydrogen nuclei can crash together and stick. And then a hydrogen and a helium can crash together and stick, forming helium, and so on, building ever larger atoms in the periodic table, up to iron. Our sun's not hot enough to go any further than iron. But eventually our sun is going to expand and become a red giant, and then it's going to contract again. And those fusion products, those elements that are being made in our sun right now, are going to be stuck there inside our sun until the end of time. They're never going to be available for making new planets. So none of this stuff that we interact with on a daily basis came from normal stars like our sun. But there are some very rare supermassive supernova stars. They have to be at least 10 times the size of our already unbelievably large sun. And when they're that big, those stars, at the end of their serviceable life as a star, they get hollowed out and gravity causes them to collapse or implode spectacularly. And when that implosion reaches a center point, again, energy densities are high enough to fuse or synthesize all the other atoms on the periodic table, all the other natural elements that we know of. So what this means for us is that somewhere in this region of space, somewhere nearby here, about 8 billion years ago, a supernova star imploded and then exploded again outward again. So it implodes, it synthesizes all these elements, including carbon and nitrogen and silicon and the things that all of us are made of. But then after the implosion, it explodes outward again and spreads all of that wonderful, hot, complicated atomic dust out into the surrounding space, where over millions of years, gravity can collect it back together into new solar systems with new planets. including planets like the Earth. So you could say that that star's death gave us life. Here's a Hubble photo of the dust clouds surrounding a different, faraway stellar explosion far from here. And you can see new solar systems being born in the dust. Almost all the atoms in your body right now, sitting here this morning, were once part of that ancient nearby supernova star. All the physical stuff that you interact with day by day is made of atoms, and those atoms all have a common origin, a common journey through cosmic time. So the seeds of you and me were present there at the dawn of time, and we are descended from stars just like those we see in the night sky. Talk about noble blood. This body is just one stage of our long, sacred journey together. We're still one thing. With all our diversity, with all the different galaxies and stars and planets and living beings, there is only one event here. It's us, we the universe, slowly unfolding in our vast and creative sojourn through time. So your life story, your body's life story at least, starts 13.8 billion years ago as pure energy. Energy so hot and pure that simple atoms were squeezed into being like diamonds from smoke. Eons later, larger atoms were explosively forged in dying stars, atoms that now make up our solar system and others in this part of the Milky Way. Okay, got it. Common origins. What about now? What does science have to say about unity and oneness now, today? Play with me. Everybody take a deep breath in and hold it. And while you're holding it, see if you can guess how many atoms of air how many molecules of air you just breathed in that were also breathed in by Moses. Okay, you can let it out. I'm not trying to asphyxiate anyone here. This is actually not that difficult to calculate. You make a few assumptions, but the results may be somewhat surprising to you. Every time you breathe in a lungful of air, you breathe in hundreds of millions of air molecules that were also at one time in the lungs of Moses, of Gandhi, of Stalin, of Joan of Arc, Hitler, Harriet Tubman, everyone who has ever lived, every animal that's ever lived, every plant that's ever lived. Speaking of plants, you may remember that photosynthesis allows plants to construct themselves out of carbon dioxide and water. Indirectly or directly, we make ourselves out of plants through the food we eat. So let's take a closer look at carbon dioxide and water. This is a drawing of the water cycle. I'm sure you've seen something like this before. Water evaporates from the ocean and goes up into the clouds, and the clouds drift over the land, and either it rains or snows down, and then through waterfalls and lakes and all that, the water eventually finds its way back to the ocean. But there's something missing from this diagram, and it's missing from every other diagram I could find about it. Anyone see something that belongs there but isn't? Well, it's us. One of the things water does as it goes around this cycle is spend time being us. Every sip of water we take contains water molecules that have recently been things like thunderstorms, glaciers, waterfalls. Water comes alive when we drink it. Something similar is true of the carbon cycle, except that carbon, as it finds its way around its cycle, it spends time being not only living things, but also things like seashells, coal, limestone, concrete. Some of the carbon atoms in your body right now were a fresh apple last month. And some were gasoline in your car last winter. Now it's you. Same thing is true with the nitrogen cycle, the oxygen cycle, the phosphorus cycle, all the elements that make up living bodies. They all go around and spend some time being us. Every year, 98% of the atoms in your body get exchanged for new ones. But exchanged with who? With what? With everything. Everything in your surroundings. Your body is like a standing wave on a river. Matter moves through you, takes your form briefly, and then moves on and becomes something else for a while. So, can you draw a meaningful boundary around yourself? Where do you stop and other things begin? Skin seems like a reasonable boundary. I'm inside and anything outside isn't me. But skin is covered with bacteria. I don't know if you knew this. But inside and outside of our bodies, we are covered almost completely with bacteria. The bacterial cells in your body outnumber the human cells 9-1 because they're so much smaller. There are thousands of species, trillions of bacterial cells, all cooperating and competing with one another, but also with the human cells that make us up. So these bacteria, microbiologists have recently found they digest our food, they protect us on the inside and the outside, but they also influence when we're hungry and thirsty, our food preferences, and most recently our weight and our emotions are influenced strongly by the species of bacteria living on and in us. So is it me who loves lasagna or we? Every human cell in your body contains dozens of mitochondria. This is the powerhouse of the cell. It's a little subcell inside of each cell. And this is where sugar is converted into energy so that we can do things. And we now know that these mitochondria are actually the descendants of ancient bacteria still operating cooperatively inside our human cells. Now, mitochondria have their own DNA separate from your human DNA in your chromosomes. So there's your chromosomal DNA with all your genes, and then there's mitochondrial DNA, which is separate and circular. You got all your mitochondria from your mother, who got them from her mother, and so on. It's inherited, they are inherited matrilineally. Now, paleogeneticists, that's hard to say, and it's a brand new field, paleogenetics. Paleogeneticists have been able to use the known mutation rate of mitochondrial DNA to determine that every human being alive in the world today is the descendant, the direct descendant of one woman who lived in Eastern Africa about 200,000 years ago. Now, this is National Geographic's map of how we got from Eastern Africa to populate every continent on the planet now. Every human being alive today, regardless of race, gender, ethnicity, we all share a common great-great-grandmother. So look around at the people in this room. These are your cousins. The simple math of ancestry suggests that everyone in this room is probably more closely related than 15th cousins. And if you're from the same ethnicity, it's probably more like 7th cousins, no more than. We're more closely related than that. There's only one family on this planet. And it's not just people. We share half of our genes with bananas, for goodness sakes. All living things on this planet are related. We are part of a single, unbroken family tree stretching back 600 million years. Now, there are so many more examples of our connection and unity from science, but the bottom line here is that we are the earth. We are inseparable from it, made of it, by it, and for it. The earth is giving this talk this morning, and the earth is sitting in those earthen chairs listening. We and it are us. One thing. One life. So there's only one story, 14 billion years long. And the characters in the story are completely interconnected at every level of existence. But what about the setting? What about space and time? A century ago, the great mystic and teacher Albert Einstein showed us that space and time are actually one thing. That though they appear different, in truth they're actually a single expression that he called space-time. A century later, one of the buzzwords in particle physics today is non-locality. We think of space-time as having a framework. Even if it bends and curves, there's a predictability to it. Things can be located in space, and two different locations are different. There's space between them, and that space is real. Quantum entanglement calls all of that into question, and evidence is piling up that space-time is non-local, meaning that location has no meaning. I won't try to explain quantum entanglement this morning, except to say that two particles that are entangled seem to communicate with one another over long distances instantaneously, faster than light. Another way to think of it is that entangled particles become a single object that can be in two places at the same time. Here's an image from a paper published in the Physical Review Letters with that title. This is entanglement giving rise to space-time rather than happening in space-time. Science writer George Musser was recently quoted in Scientific American saying, quote, "Multiple branches of physics now suggest that at a deeper level there may be no such thing as place and no such thing as distance." Non-locality suggests, that's the end quote there. Non-locality suggests that there's only one place here, one location, even after 13 billion years of expansion. It's as though we are still in a singularity, but somehow diversified. Before I close, let me share something I found amusing, also from Scientific American. Keep in mind, this is a magazine whose every issue contains an essay by skeptic Michael Shermer, whose career is all about debunking the supernatural. The cover story of a recent special issue was titled, "Is the Big Bang and all that came from it a holographic mirage from another dimension?" Sounds like something straight out of the Course in Miracles, doesn't it? So what science says about unity and oneness is that your life story and my life story and the moons and the Pleiades and the Andromeda Galaxy's life stories are all the same story. Because there's only one story, and there's only one character in the story. We, us, the universe. I say this not as a prophet or a psychic, but as a hardcore, mainstream science educator. As the great poet and teacher Rumi said, "You are not a drop in the ocean. You are the entire ocean in a drop." So what do we do with this knowledge? Realistically, most of us will probably do what most people have done with new revelations going back forever, which is forget them in the hustle and bustle of daily life, or at best relegate them to an affirmation or a prayer or two on Sunday mornings. That is supposed to be funny, and funny because it's so true. Honestly, I don't know what to do with this knowledge except to meditate on it, take it in, make meaning of it. For me, the first step is to use me less and we more. We the people, yeah, but also we Earth. We the universe. We reality. Like the bumper sticker, think globally and act locally, I try to think of myself as an expression of the universe, a tiny cell in the body of something vast, benevolent, and dependent on me like I'm dependent on each of my own cells. I especially try to remember this when dealing with people who take advantage of me or people with extreme ideologies. We need them in order to be us. Just like a forest community needs both poisonous mushrooms and beautiful flowers. It doesn't mean I shouldn't be politically active or maintain good boundaries or that I should be happy to eat poisonous mushrooms. You know, my muscle cells and bone cells are completely different from one another, performing nearly opposite roles in my body. But I'd be a mess if my muscle cells convinced all my bone cells to be just like them. Just as there are feedback systems among the diverse cells in my body, I need to communicate my truth loudly and firmly. But I can do that with grace and compassion and respect, knowing that those people, whoever they are part of me, part of we, part of the still evolving singularity that is the I am. Another thing we can do with this knowledge is just share it. You know, there's this running argument between atheists and believers for decades, almost centuries now, about the existence of God. And more often than not, they both demonstrate values that are the exact opposite of the words they're saying. So when people are spewing the same old arguments with the same old self-righteousness, I like to interject that there's plenty of reason for praise and gratitude that we can agree on. And maybe that's more important than our personal vision of God, which is almost certainly inadequate and incomplete anyway. I've come to believe that this argument about the existence of God misses the whole point of a spiritual life, which is our relationship with the sacred and transcendent. It just doesn't matter to me whether you believe in God or not. I want to know how you express your reverence, how you treat creation in all of its expressions. Arguments about who created it are a distraction and a destructive one. So my last suggestion for what to do with this knowledge is to treat everyone and everything you encounter as an essential part of your larger self. Because it is. Science says so. Thank you very much for inviting me. It has been an honor to speak in this now legendary congregation, and I really appreciate it.